So, today we're going to talk about a chemical with a truly wild story. It's a chemical that's been hailed as a lifesaver and condemned as a notorious poison. It's a story about incredible success, an unforeseen disaster, and a debate that is, believe it or not, still raging today. Let's get into the persistent paradox of DDT. Just let that sink in for a second. That's a quote straight from scientific literature. What that means is, right now, inside your body, there are traces of an insecticide that was mostly banned decades ago. It's inside every bird, every fish, every single person on this planet. And that really is the big question here, isn't it? How on earth did we get to this point? How did this thing that was supposed to be a miracle weapon against disease end up as a permanent part of our global environment and even our own bodies? Well, to understand that, we have to go back to the beginning. You see, before DDT was the villain of the story, it was the hero, a total game changer. Its insect-killing powers were discovered back in 1939, and it didn't take long for people to see it as a modern miracle, a real savior in a spray can. And the scale of its impact, it is just staggering. It's estimated that DDT helped 1 billion people live free from the constant threat of malaria. Think about that number. That's not a statistic. That's millions upon millions of lives saved. And it wasn't just malaria, oh no. During World War II, DDT was absolutely crucial for stopping typhus outbreaks among soldiers. And after the war, its use just exploded into farming and forestry, wiping out all kinds of pests. It was like this all-purpose weapon against some of our oldest and deadliest enemies. And man, did it take over fast. Discovered in 39, already in mass production by 43, and by the mid-50s, it was dirt cheap. I'm talking a quarter per pound. So why would you use anything else? Its power and low price meant it spread across the entire globe. But that success came with a massive hidden cost. And here's the twist. The very thing that made DDT so effective, the fact that it was so stable and long-lasting, was also the very thing that triggered an ecological catastrophe. Okay, so to really get what happened next, you have to understand this one key idea: bioaccumulation. It works like this. A tiny organism absorbs a little bit of DDT. Then a small fish eats a bunch of those tiny organisms. All that DDT now builds up in the fish. Then a bigger fish eats a bunch of those smaller fish, and so on, all the way up the food chain. At every single step, the poison gets more and more concentrated. So here's the kicker. DDT does not go away. This stuff is incredibly stubborn. It can take 10, maybe even 20 years for it to break down inside a single person. And its main metabolite, a chemical called DDE, can stick around for an entire lifetime. It just builds up in fatty tissues, passing from prey to predator, getting stronger and stronger as it goes. And you can see the results right here in people. Look at the data from the US. The concentration in body fat literally tripled in just 6 years at its peak. Same story in Italy. Now, the levels do drop a lot after it was banned, but look closely. They never, ever go to zero. And for wildlife, the effects were nothing short of devastating. Scientists found DDT everywhere, from remote deserts to the deep ocean. This is probably what you've heard about. It famously caused the eggshells of birds like falcons and eagles to become so paper-thin that they'd break just from the parent sitting on them. This led to a complete collapse in their populations, pushing some species right to the brink of extinction. So, what about us? If it was doing that to wildlife, what was it doing to people? Well, this is where the story gets a lot murkier, and frankly, a whole lot more controversial. In the lab, the evidence seems pretty cut and dry. You've got decades of studies on animals, mice, rats, even monkeys, and they show that DDT and its byproducts are carcinogenic. They cause tumors in the liver, lungs, and adrenal glands, and the more they're exposed to, the higher the risk. And yet, when you look at the studies on humans, the picture gets really blurry. Why is that? Well, it's just incredibly hard to prove a direct link. Think about it. Pretty much every single person on the planet has been exposed. So where do you find a control group, a group of people with zero exposure to compare against? You can't. And that's led to this situation where the evidence in humans is often called inadequate or inconclusive. Now, one of the biggest red flags is that it's known as an endocrine disruptor. Basically, it messes with your body's hormones. Its main metabolite, DDE, is especially good at blocking male hormone receptors. So naturally, there are huge concerns that it could play a role in hormone-related cancers or other problems, like the premature births it's been linked to.
And this next part is, well, it's pretty alarming. Because DDT builds up in fat, it gets concentrated in breast milk. Some studies have found it in 100% of the samples they tested. And for a breastfed baby, this could mean their daily intake of DDT is way, way higher than the levels considered acceptable by global health organizations.
So this all brings us to today, and to the really tough part of this story, the unresolved dilemma. If we know all of this, all these risks, why is DDT still being debated? Why in the world is it still being used? Well, the dilemma is just incredibly stark. On one side, you have the case for a total ban, and it's a strong one. It's a global contaminant, it devastates wildlife, and it's a potential risk to our health. But on the other side, the argument for limited use is just as powerful. It remains one of the cheapest and best tools we have for fighting malaria. For poor countries, there often just aren't any other good options. And let's be clear, this isn't some theoretical debate. This is happening right now. As you can see, dozens of countries, mostly in Africa, Asia, and Latin America, still rely on DDT to control the insects that spread deadly diseases. And the stakes could not be higher. Just look at what happened in South Africa. They stopped using DDT for indoor spraying, and almost immediately malaria cases skyrocketed. The consequence of that ban wasn't theoretical at all. It was measured in human lives. They had no choice but to bring it back. So we're left with this incredibly difficult question. DDT is a confirmed ecological poison. It's a potential human health risk, and it's a proven lifesaver. It's a paradox with no easy answers, forcing us to weigh known, tangible damage against known, tangible benefit. So, when a poison can also be a medicine, how do we possibly choose?